All right, so before and statistics. Go ahead, let's pour you in. Really? In stats, we have data-driven, which is like test scores, 78, 82, 96, 96, and 98. And what were you asked to find with those 5 test scores? Everything. What? Mean, median, mode, range, mid-range, variance, and standard deviation. And then I said, besides the data-driven set, you can have a frequency distribution, which is basically a 25-cent word for a table, not X and Y, the word, but it has a class on one side, and then the count on the other. And let's say that this is the class, this is one person in the class, and this is the class A, B, C, D, F. 2, 3, 8, 4, 6, 1, 4, 2. All right, so that is a frequency distribution. Now, with probability, we have talked about in chapter 4, we've talked about basically the data-driven probability. In other words, I'm going to put this in other words, data-driven, I'm going to put this quotation marks because that doesn't mean anything, y'all. It's just something that I use. Data-driven probability. In other words, we talked about rolling a die. And what is the probability of getting a 6 on a die? 1 out of what? 6. That's the theoretical probability. And then we roll the die 15 times, and 7 times out of the 15, it comes out to be 6. All right, that's physical probability. So we did that. Probability of rolling a 6 after 15 times came out to be, I think, let's use 3 over 15. All right, so we've got regular probability, and we got theoretical probability, physical probability, and then we talked about the multiplicative rule and the what? The additive rule of probabilities. So that kind of lines up with this. And now we're going to do what we call in chapter 5, this is chapter 4, and in chapter 5 we're going to talk about a probability distribution, which is a 25-cent word for another table, and except for head count over here, it's going to be what? Probability. And with the event happening over here. A good example that I use or is used is what is the probability of the World Series going to 4 games, 5 games, 6 games, or 7 games? I mean, 4 games. Let's see, how many are there? 7. So once 4, yeah. 4 games, 5 games, 6 games, and 7 games. Or 5, 6, 7. It could be that way. So a good example of probability of World Series going to a certain amount of games, N games. All right? World Series going to 5 games, 6 games, and 7 games. And you have a probability, they figured the probability of this to be 0.25, 0.50, and 0.25. So if you was to make a bet that the World Series is going to go to 5 games, you probably would lose your money. But if you won, it would probably be what? A lot of money, because probability is kind of low. If you bet that the World Series is going to 6 games, you wouldn't lose as much money, but you wouldn't get much of a payoff because what? Probability is higher. And of course, 7 games the same way. And that's what a probability distribution is. A probability distribution is nothing but accumulation of what? Your data driven. Basically, these guys over here, over here. See? That's the difference between the two. Just like data driven in statistics, frequency distribution. Whenever you see that distribution, that means you've got a table in there somewhere. Okay? And that's what this is. Now, there's two things you got to watch with these probability distributions. I don't do it, but there are some teachers that will put them on a test. I try not to do it unless I don't know about it. Usually I don't put them on there unless it regenerates as one. One, all the probabilities have to be between what? 0 and what? And 1. In other words, if you've got a probability distribution, well, just like the one we just had, this is X, and this is probability of X happening. 5 games, 6 games, 7 games. And I go 0.25, 1.3, and 0.25. Well, we can't have that. We can't have that because probability only goes to what? 1. So you may have a homework problem that has a 1.3 in there. Don't do it. Just mark through it and say cannot be done or whatever it says. Don't even try it because you're going to get a wrong answer if you do, because you can't calculate with this. The calculations were not derived above 1. The calculations were derived from 0 to 1. All right, so that's one thing. Second thing you got to watch for, and that's when this happens, the summation of P of X has to equal 1.001. I'm going to put plus or minus 0.00001. In other words, they give you a little bit of leniency. If you look in the book, if you've got a book with you, let me find it. Where's my book? Dang, oh, somewhere in here. There it is. The summation of P of X is equal to 1. But they do give you a little bit right here. The sum of all probabilities must be 1. But sums such as 0.999 or 1.001 are acceptable because they result from rounding errors. So you need to make a note of that. There's your 2 right here. Now, what does that third one mean? The third one means if you add up the P of X's, it should be equal to 1. Well, the problem that we had a while ago, is it going to equal 1? Why? Well, there's 0.5, and that's 1.3. $1.30 plus 50 cents is what? $1.80. Can't have that. All right? So you would put right here, you just draw a line right here, 1.80, and that wouldn't work. 1.80 will not work. It's got to be equal to 1 or 1.001 or 0.9999. Okay? So you got to watch for these. Now, mainly on the homework, because unless I do it accidentally, I do not put those on the test. There's one. That's okay because 0.25, 0.5, and 0.25 equals 1. And that's the probability of number of girls in 2 births. And that's what it'll look like. was going to find a problem that'll be like on the test. Just told, okay, here we go. This is what I want you to know. And they're on the page right here. On page 200. This is what you need to know for whatever section this is, 5.2. You need to know formula number 1, 5.1, and formula 5.3 and formula 5.4. Mm-hmm. And the reason I use 5.3 is just personal preference. And if you'll notice, just like before, what is the variance? What's the relationship between the variance and the standard deviation? What's the relationship? Just like before. Say again? I heard, well, it's what? Well, what's the difference? What's the difference in the formulas? The standard deviation is always the what? Square root of the... I told y'all that in the first chapter. I told you that I usually don't worry about the variance. I'm worried more about the what? Standard deviation. And the standard deviation is the what of the variance? Yeah, I guess. If you enunciate, that means square root. Yeah. Now, all you got to do is know how to do these formulas. That's all. Once you do that, you're good to go. Now, I've told you what x and p of x are. X is the event, and p of x is what? The probability of the event happening, Hubert. That's right, class. Anytime you got a p in front of something, that means what? Probability of that event happening. So, let's do an example. Because it doesn't do you any good to have these formulas and not do an example. So, let me find one. I just want a table. I don't want that. That's too complicated. Just hold on and I'll find one. When I find one I like, I'll stop. I get to homework. Okay, do y'all have homework in this section or what? There we go. Alright, here's one right here. I don't care about what it is, but okay, 3 births. Probability, number of girls in 3 births. 0 girls, 0.125. 1 girl, 0.375. 2 girls, 0.375. And 3 girls, 0.125. Do y'all remember doing the boy, girl? That's what this is. Okay, all they did was they put it in decimal form and they changed the probability just a little bit. So write that down. The first thing you want to do is make sure that every one of these is between 0 and 1, are they? And then add them up to see if they equal what? 1. Well, 0.125 and 0.125 is 25, right? And 37, that's dang old what? 75? That's 75, and this is 25, so it equals 1. So I want you to write that table. I'm going to snip it. And I want y'all to write the table down. And then I'm going to take it over here and I'm going to put it, I don't want to put it right here. I'm going to use this, and I'm going to go back here to the formulas. What was the formula on 200? I watched a good movie last night.
What was it?
Thank you. McFarlane. That's a good movie. Y'all don't even know what it's about? It's Kevin Costner about the 4 Mexicans that could run. It's a real good movie. Be all crying at the end of it. All 4 of them got ran over by a transfer truck.
That's awful.
No, they didn't. It's a good movie, okay? He basically is a football coach at this real nice high school, and there's a jerk as a high school quarterback, and they're losing the game, and in halftime he throws a shoe at him, just to throw it at him, and it bounced off the locker and hit him in the face, so he got fired. Okay? Got fired and went down, basically could not get a job anywhere, and he ended up in the bottom half of, I think, California, down right near the Mexican border, or somewhere down there. It's called McFarlane. It's a good movie. And he was supposed to be, he was the assistant football coach, and one of the kids was injured, and he said, you don't need to go back in. And the head coach called for that guy to go in, and he said, he don't need to go in, he's hurt. So the head football coach goes to the principal and says he can't work with him. They had an altercation. So then he got fired from being an assistant football coach, and he said, I need a track coach and a life science teacher. So he said, you be the track coach. So he's the track coach, and he saw these Mexicans running across the field, and he decided to have we've got a cross-country team. And they won the state championship. They beat everybody. It's a good movie. All right, there's our formulas. And here is our table. Okay, this thing won't let me insert. I have to insert this way. Okay, there's our table. Okay, so what we got to do? Well, look at your first. What is that? The mean is equal to the summation of what? X times what? So what are you going to do? You're going to make another column, and you're going to call it X times what? And you're going to multiply those 2 columns together. I'll do the first one for you. 0. I'm smart. 0 times anything is 0, so that's 0. Your first one is 0. I'll even do the second one for you. 1 times 0.375 is 0.375. I'm just so smart. Now I'll let you do 2 and 3, because those are real easy. I'm going to do it by the spreadsheet. Not because you have to use the spreadsheet. Why am I doing it on the spreadsheet? On its organization. Because I don't want to write on the board, because my columns are not straight and my letters are not all the same, and I just don't want to.
Can you get a number over one?
Huh?
Can you have a number over one?
Yeah, that's just for the initial. Those 2 rules are just for the initial distribution. All right, so I'm going to pull up my handy dandy spreadsheet. And I don't know what that is, go away. And pull this down, make this small, not that small, but that small, and I'm going to pull this over here, and it's going to disappear. So anyway, I'm going to put X right here, And that's going to be 0, 1, 2, 3. And then P of X is going to be 0.125, 0.375, 0.375, and 0.125. Of course, I can't stand for it not to be centered, so I'm going to center it. There. Okay, so there's our table, and our information is, I'm going to put the table, that ain't going to work. I'm going to have to put the table right here just so you can see it. You don't have to see it, but I've just basically put it up here. All right, our first column is going to be X times what? P of X. And equals this guy times this guy. And you might need your calculator for that. And then copy that down. And then what are we going to do with all of those numbers? Add them up. Dang old summation. And those three numbers. And what is that number? 1.5. What is that? That's your mean. See how simple that was? 5.2 and 5.3 is even easier. Okay? Okay, you do not have to use the Excel spreadsheet. The only reason I'm doing it is so it's nice and organized for y'all to see. So you need to be writing these columns down. All right, now let's go back to our formulas. Let's go back to our handy-dandy formulas. All right, how do we find the variance, which we don't care anything about, but how do we find it? Well, you got to have X what? All right, what about P of X? Have we got that? Yeah, we got that. So we just need what? Does this sound familiar? What does it sound familiar? How does it sound familiar? Where did you have to find X squared before? We're finding the mean of a what? Frequency distribution. So you're doing the same thing, except a different formula. So we go back to our handy-dandy, and what is this next column going to be? X squared. Y'all are so smart. I think it's the teaching. I really do. Equals this squared. And I'm going to copy that down. And there's your numbers there. Now you should be able to do those in your head. Okay? All right, now we got to have one more column. Let's go back to our formula. What is it? X squared times what? X squared times P of X. So our column is going to be called X squared times what? X squared times P of X. Now, what is the most common error students make on this column? Anybody want to take a guess? They picked the wrong column. All right? It's very easy to do when you're working and you're trying to get the problem done on a test or whatever. You got your columns and you pick X instead of X squared. That's the number one problem. So, what you do is you take your handy-dandy X squared column, and that is right here. I'll do the first one for you, be 0, times P of X, and then you copy it down. Oops. And then what are you going to do with those numbers? Add them up. But that's not the answer, because you got to do something else. Let's go back to our formula. What do you do after you take X squared times P of X and add it all up? You subtract the mean squared from it. So we take our handy-dandy Excel spreadsheet, and we're just going to go down here and put variance is equal to, and I'm going to take 3, and I'm going to subtract parentheses what? That should be, no, 1.5 times 2 is 3. To the second power, close parentheses, and there is your variance. All right, so somebody tell me what we're going to do to get the standard deviation. Take the square root or raise it to the 0.5 power. Wasn't that awful this happened? What happened last night in Charleston? Yeah. No, did they catch him?
Yeah.
Well, they apprehended the suspect. They kind of found him guilty.
They did find. Where did they find him?
It hasn't said, like, there's.
I know they know who it is, but they were on the lookout for him when I was.
The police haven't confirmed that they found him, but there's like people saying that
Okay.
they apprehended. What happened?
I think it's racial. I think it's racial. There was a shooting.
I hope it ain't.
Well, the thing is, they found him. Pictures of him on Facebook. He has a car. His car has like some Confederacy thing. And he has
Some
flags
idiot.
on it.
Well, he said, he told the lady that was in the church that he wanted to go tell what happened, that he, that like, they were taking over and that he had a gun.
He wore
That's
some
like what he
flags
told
on the
me.
jacket. The flags were from different like settlements in Africa in like the European.
First of all, just consider the source. The guy is crazy. I just hate that he killed. I wish one of those people in that church had a gun, because they couldn't shoot. They say he had to reload the revolver 5 times.
Then why didn't someone take that time to tackle him? That's probably scared.
I don't know.
People don't think.
I don't know.
That's when you like you're the crazy.
I would go absolutely bonkers. I would probably, yes, I probably would. I'd be picking up a pew and throwing it or something. All right, so there's your what? Now, if we've got the mean and the standard deviation, what can you draw?
A bell curve.
Mm-hmm. Which you better get used to doing it, because in chapter 6, that's all you're going to be doing. And I'm just going to do 2. And what goes in the middle? The mean. So that'd be equals the mean. Ugh. It's not centered, I'm sorry. Drives me bananas. I can't stand that. Alright, and then equals 1.5 plus what? I can't see up here. Plus, y'all sitting in the dark, variance. And equals this plus that equals this minus this equals this minus this. Now, I know it doesn't mean very much, but the reason I want you to do it is just for practice for chapter 6. And that's why I've been showing y'all to do this ever since the first chapter. Okay? I meant the first unit. If you're asked to find the mean and standard deviation, somewhere down the line they're going to ask you to do this. Okay? Or if you're given the mean and the standard deviation, somewhere you're going to draw this. And what does this mean? That means that 95% of the population falls between 3.23 babies and negative 0.23 babies. Now, it's not realistic because there's no such thing as 0.23 babies, much less negative 0.23 babies. But what they're saying is that having 3 babies that are girls is not unusual. Very unlikely, but it's not unusual because it's close to the 95% of normality or normality. Okay? That's how you work the problems in 4.2. Not very difficult. Let's do a nerd. And then we'll do the easy ones. the little formulas that I'm going to show you. Okay, here's one, or there's one. All right, let's do number 13. It says, in a survey sponsored by Coca-Cola, subjects aged 15 to 65 were asked what contributes most to their happiness, and the table is based on their responses. First of all of them are between 0 and 1. What else do you check? You add them up. Dang old 70 cents, that's 85 cents, so that'd be 80, what? 80, 90, 92 cents, something like that. 90, what's the problem? It's over. So, you can't do it. Simple as that.
Why they put it in
To test you. See if you go for it and see if you try to do it. All right, so let's add these up. Somebody, I'm going to let y'all do the adding on this one. Add them up right quick. 0.003, 0.025, 0.111, 0.279, 0.373, and 0.208. Okay, so we can do number 12. So let's take our handy dandy tool and let's just do this. Let's just take that one and save, yes, and go to our handy dandy whiteboard and insert. Y'all are impressed, aren't you? There you go. Groups of people aged 15 to 65 are randomly selected and arranged in groups of 6. The random variable X is the number in the group who say that their family and or partner contribute most to their happiness. So you got 6 people that say that their family contributes to their happiness. 5 people, or 5, let's see, it says X is the number in the group who say, okay. And the directions is find the mean and standard deviation. So I'm going to give you all a minute to work on that. And I'm going to pull up my handy dandy spreadsheet. Hold on. There we go. As soon as I can move it, it won't let me move it. Okay, fine. There. See if you can make all your columns out, and see if you can fill everything out and add everything up and see what you get. Okay, so your first column is going to be what? X times what? And hopefully y'all check this one on your calculator, because I don't know if I can do this math in my head. And copy that down. and check your answers. And when you add that up, you basically have the mean. Let next column, we're going to square what? X. And then we're going to multiply x squared. See, I picked the wrong answer. What did I do wrong? Oh, I didn't square it. Hold on, let me get out of this. I didn't square it. There, how's that? And then equals that times p of x. Make sure you pick the right. And then copy that down. And then get a summation there. And your variance is going to be equal to the 22 point blah 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 minus parentheses this what squared, and I got 1.08, and the standard deviation is going to be equal to that raised to the 0.5 power. Which would be 1.04. And it should be what y'all got. So expect a couple or three of these on the test, because that's what I put on the test. And you need to find the mean and the standard deviation. Sometimes they may ask for the variance. Depends on the question. Did all y'all get that? Or most of your numbers, I hope they match up if you hadn't finished it. Wait till everybody gets through right. Okay? Alright. So that's 4.2. Make sure, basically, when you go to the homework in the book or if it's got a table, that's a test question. Okay? If they don't have a table, I'm probably not going to put it on the test. Okay? Alright. 5.3 I think it's 5.3. Somebody check and see. Yeah, 5.3. I think we just go to 5.4. You don't have to. No, we don't do that. I don't do that part. I'm trying to find my formulas. No, we don't do 5. Somebody look in your syllabus. This don't look too familiar. Yeah, there it is. NP and X. Here we go. Here is the formula. This doesn't look like the formula, but let me go back. You know, there's the formula. I just must have missed it. It must be on the bottom of the page somewhere. There she is. All right. Look on page, if you got a book, look on page 212. Now, what's the difference in these formulas, and what's the difference in 5.3 and 5.2? 5.2, you're given a probability distribution, right? In other words, probability of this event happening, probability of this event happening, and it's in a table. These are not going to be like that. These are just going to say, you know, you flip a coin 50 times and you got tails 26 times. What is the probability if you use that same coin and you flipped it 100 times? What would the probability be? It's going to be a paragraph, and it's going to ask you for the probability given the information.
Why is there exclamation point?
That's factorial. It's chapter 4. You don't remember chapter 4? Okay, say it one more time. A little bit louder. She's going to throw something at me. She said she wasn't here. Oh, wait a minute. I have videos that you can watch. Huh? All right. Now, the good news is you don't have to use this formula because it's a pain in the butt to use. Okay? But I have to show it to you because some people don't have a TI. And if you don't have a TI, it's really going to hurt to use that formula. Okay? I would borrow one, arrange to borrow one while you're taking a test, or make sure it's got NP and X on it, and I'll show you which one to use. But that is the formula. I do not use the formula very much unless I'm asked to use it. Most of the time you can get by with your calculator. The problem is going to give you NP and X. All right? It's going to give you that. And all you got to do is type it in that order. N, P, and X. You can't type it in any other way because the calculator have a cow. And then y'all go into conniptions when there's the formula again. When the calculator gives you an error, y'all go into hysterics. Second vars, binomial PDF. It's on page 217. So when you go to your calculator, second, that's the orange button, and then vars is variables, V-A-R-S, right over here beside the clear button. And which one did I say? Binomial what? PVF? Did I say PVF? Okay, there it is. Number 0, or you can just hit 0. Enter. And it's going to ask you for N, P, and X. That's the way you type it in. Somebody's going to come in here. What day is today? Somebody's going to come in here Tuesday and say, Hubert, I've tried to type it in, and I've tried to type it in the calculator, and it keeps giving me an error. What are they not doing? They're not typing it in the order N, P, and X. So if the N is 50, you type in 50. In other words, I flipped this coin. I got a coin in my pocket. It's the only coin I got. And I flipped it 50 times. And when I flipped it, or 100 times, I flipped it 100 times. That makes the math easier. And when I flipped that coin 100 times, 57 times it showed up tails. So what is that probability? 0.57, Hubert. That's right, class. That's P. P is always going to be a percentage or probability. Then what is the probability of me getting tails if I flip this coin 500 times? And, or let's say flip it, let's say something, let's go below 100. Let's go, if I flip it 60 times, then that's X. Oops. Don't use keyboard on the input. Don't do that. And then hit enter. So if I flip it 60 times, it's going to go to a 0.06 or 0.077%. I flip it another 60 times.
Mine didn't do that.
Yeah, when I did the 500 thing, it said 0.
No, 500 I didn't. I said 60. I changed it.
Yeah, but is that like possible?
Okay, did you put a comma between them?
Yeah, mine got something different from that.
Then you might have hit the wrong binomial. There's two of them.
I know that it's
Well, let me do it again. Second vars, binomial, PDF, 100, comma, 0.57, comma, and 60.
No, you're not doing it wrong. Mine just has, it says trial and it has B and it has X value and it has space.
Oh, you got a different setup then. Let me see it. Okay, trials would be 50, or what did I say? 100. And then P is 0.57. And then the X value is 60. You just have to hit enter a couple of times. That should be your answer. So if you do it another 60 times, you've got a 7% chance of hitting tails or whatever the question. I don't know what the question is going to ask. I'm going to show you some in just a minute. Now, P can be given to you three different ways. I'm going to show you the three different ways so you can look for them and not say, well, I don't know where P is. Broke my dadgum. P can be given to you, is given several ways in the question. It can be given to you as a ratio, 4 over ratio, ration. 200 people out of 600 hate their job. Okay? So if you're given something like that, what is P? Well, it'd be 200 out of how many? 600, which would be 2/3 or 2/6, which is what? 1/3, which is point what? 33. That's right. So that's 33% or 0.33. Because I took the 200 and put it over the what? The 600, thank you. And the zeros cancel. That gives you 2 over 6, which is equal to what? 1 over 3, which is equal to... You see how P can be given as a ratio now? And that's where students usually, they read the question, and the first thing they ask is, Hubert, where's P? P's not given. I don't see a decimal. Well, that's fine. 2, they can give it to you as a decimal, which y'all are used to seeing, or they can give it to you as a what? Well, that is a fraction here. Percentage. And you got to change it to a decimal, which is, they would give you 33% and you change it to 0.33. The reason I'm showing you these is not to insult your intelligence. I'm showing it to you because when you see a problem, you're going to say, that's not a decimal. And you're going to get confused. That's why. So probability can be given as a ratio, aka fraction. But sometimes they'll give you the fraction, or sometimes they'll put it in a sentence and you got to extract the fraction out of it. Okay? So, with that information, let's go to our handy dandy book. Can't find the book. There we go. And let me find you a problem that pretty much, see how short the chapter is? Very short. Let me see if I can find one. Try and find one with probability in it. Here's where they give you n and x, but they give you the probability and the answer. That's not what I'm looking for. One that has it, and I will get there in a minute. As soon as I'm trying to find test questions for you. There we go. Based on Bellows' survey, this is number 33, of adults, there is 0.48 probability that a randomly selected adult uses a tax preparer to file taxes. Find the probability that among 20 randomly selected adults, exactly 12 use preparers. So which one's N? N is always your what? I heard. Say it again. What is N always? The what? The biggest what? Biggest number. I think I've said that like 500 or 600 times, haven't I? Go. Don't ask, just go. Okay? All right? Go. All right? So N is always your biggest number. So which one's N? It's a miracle. All right? So which one is P? 0.48. And which one is X? And you type it in. That's how simple these are. And there's your test questions right there. There's examples of the test questions I'll pull in. So you take your handy dandy calculator and you type in second entry, and we'll make this 050, or what's 020. Now why did I say 020? Well, I'm just keeping that 3 digits right there. If you want me to delete the 0, I'll delete the 0, but some people have a cow, better delete it. Alright, and the probability is 0.48. And the number of tries is, or the X is 12. And you hit enter. So there's a 10% chance, or a 0.10 probability. It says find the probability that among 20 randomly selected adults, exactly 12 use a preparer. Among 20 randomly adults, is this unusually high? Is it unusual? No. Because what? It's above what? 5%. So the answer would be no, it is not unusually high. It is normal. Right, Lauren? Normal. Nothing. She's the one that came up with normal. All right. So that's the answer there. So let's do this one. The U.S. Department of Transportation recently reported that blah, blah, blah of U.S. air flights arrive on time. Find the probability that among 12 randomly selected flights, 10 arrive on time. So this time they give you P, but they give it to you in what? Percentage. So you got to move the decimal over 2 places. So your P is 0.805. So take second entry, and we're going to change that to, I done lost the question, there it is. N is 12. Point, second insert, 0.85. No, 0.805, sorry. And delete. And 10. So there's a 30% chance, or a 28.7, or a 29% chance, or 0.29% chance that what? It says find the probability that among 12 flights that you randomly select, 10 arrive on time. So you got a 20% chance that they arrive on time. Is that good? No, that sucks. Because what would be a good number? 100, 80, 90? So that means, do you need to kill yourself to be on time? No. And that's what it's asking. It says, does that probability apply to the author of this book, who must make 12 flights originating in New York? He's not narcissistic, is he? Anyway, who must make 12 flights originating in New York? I don't know. Does that probability apply to the author? I don't know. Who must make 12? Yes, I would say it would apply. Because it says, does it say out of New York, or does it just say randomly selected? 12 randomly selected. Anyway, online banking, based on data from USA Today, 72% of adults have security concerns about online banking. Find the probability that among 30 randomly selected, exactly 20 have concerns. So N is 30, P is 0.72, and X is 20. Second function. So 30 goes right here. And 0.720 and 20. A 12% among 30, let's see, it says, find the probability that among 30 randomly selected, exactly 20 have security. Is there a very high probability of 20 having security concerns? No. There's a 0.1%, there's a 0.1 probability that 20 out of 30 people have concerns about online banking. So there's 3 test questions. Now, if you had to use the formula, it would take some time, but I'll show you right quick. Y'all just remember these. Y'all wrote these down, didn't you? Or the numbers at least. Go back to the handy dandy book, and let's go back to the page. Somebody tell me what number it was on. Do you remember? 217. Okay, I done passed it. No, you lead me astray, Miss Skyward. Why are you doing that? Yeah, the formula. 212. Yeah, but I wanted the original. Alright, so in this problem, the last problem we did, N is equal to what? 30? P is equal to what? And X is equal to 20. So that means P of X, P P of 20 equals 30 factorial over n minus x would be 10 factorial times 20 factorial, and take that, multiply that by 0.72 to the 20th factor, or to the 20th power, times, well, what's Q if P is 0.72? Q is the complement, so what is Q? 0.28? 0.28, n minus x is 10. And you do all that on the calculator. If somebody give me 30 factorial, type in 30 and then factorial, what do you get? Times 10 to the what? Times 10 to 32. And 10 factorial times 20 factorial. It's going to be a VA number, which is going to make this a very small fraction.
8.83
Oh, it's not going to be that. Okay. And that's going to be a regular number then. All right, do that. I don't know what that comes out to be. You don't really care. But then you're going to take 0.72. Somebody take 0.72 and raise it to the 20th power. What do you get? 0.0014. And then take 0.28 and raise it to the 10th power. .28, caret symbol 10. 2.96 times 10 to the what? 2.96 times 10 to the negative 6, which is a very small what? Fraction. Decimal. 0.0 is 5 zeros. So that would be all this times
That's
0.00.
Point 14, that's not supposed to be 0 there.
How many zeros? How many? I think we got to have a calculator class. 0014 and 0.0014, and then this is 0.0000, I think 5 zeros, 29. Basically, what are these two decimals going to do to this big number? It's going to dwindle it down to nothing, just about. Because you got a bunch of zeros here and a bunch of zeros here. That's going to bring this one down. So, and if you do this math, has anybody done this math yet? What do you come out with? You should come out with the same thing we came out with the NPX. Huh?
12%.
Was it 0.12? And was that the same thing we came out with before? Yes, sir. Yeah. Yeah, I just, had those dots there and keep on going. I was just writing it down. No, I wasn't rounding. No, do not round. Round at the very end. Okay? So that's how you would use if you use the formula. So you could borrow a TI when you're doing the homework or doing the test, borrow it or share it or whatever, but the TI comes out handy in these sections. And that leaves us with what? 5 point what next? 5.4? Which one we go over? Somebody look in your syllabus. 5 point what?
4.
5.4. This one is the square root. NPQ should be, yeah. Okay, I don't know if y'all can handle it or not, but it's some real high level mathematics. The mean is equal to n times p. The variance is equal to n times p times what? Q, which is the complement of p. And then what do you do to the variance? Take the square root. Y'all see a pattern? Whenever you want to get the standard deviation, you take the square root of the variance. So really all you need to know is the mean and the variance and just take the square root. This one you're going to be given the same type problem, except this one it's going to be worded a little bit different. The brand name of McDonald's has a 95% recognition rate. What is that 95%? What is that? What is 95? That's a percent, right? Percent means what? Huh? Yes, thank you for the interaction. P can be given as what? As a decimal, as a percentage, or a ratio. To get P. Okay? What did you say?
I'm getting my remote.
Oh, I'm sorry. Thank you. I'm sorry, Vanna. All right? Dang women. All right. So, here's the problem. 95 is what? P, Hubert. Thank you, class. So what is Q? Huh? I heard 5.
Somebody said,
Oh, yeah. I said 5. It's wrong. No, I'm just kidding. So Q is 5. All right. So the mean is n times P. So that means 95% is P. So all we got to find is n. So here we go. A special focus group consists of 12 randomly selected adults. Find the mean and standard deviation of 12 people, knowing for such random groups of 12 people. Okay, 12 people knowing the recognition or whatever McDonald's logo looks like. So that'd be 95 to 0.95 times 12. That's how you find the mean. And to find the standard deviation, you take the mean and you multiply it by 0.05. And then to find the standard deviation, you take the square root of that. I'm going to show y'all something. Write it down, Anna, please. So in this problem, P is equal to 0.95. Therefore, Q is equal to 0.05. N is equal to 12. So the mean is equal to P, which is 0.95, times 12. Now, it's not that hard to do percentages. What is 10% of 12? Ten percent of 12. Don't you dare put that calculator up. What's 10% of 12, people? You move the decimal one place.
1.7.
Yes, Ms. Coward, thank you, 1.2. I know, y'all just don't want to talk. Y'all knew that, right? So, we've got 9 of those in there, right? 90% is 9 times 10, right? So 1.2 times 9 is dang old 10.8. So I'm going to put 10.8 right here. 5%. Well, 1% is 1.2. What is 5%? What's half of $1.20, people? What's half of $1.20? Huh? Thank you, Miss Coward, again. So, add 0.6 cents. I get 11.4. It's a miracle. So, your mean is 11.4. Now we're really going to shake up some things. Because you got to get your standard deviation, your variance, you got to take your mean and multiply it by what? Okay, now, what is 10%? Now, let's just work with me here, okay? What is 10% of 11.4? Catching on, good. 1.14. Now, that's 10%. What's half of $1.14?
57.
Thank you. So what is my variance? 0.57. Now somebody go ahead and take 11.4 and multiply it by 0.05. It's a miracle. I don't even have a calculator. What's the 6 cent for? Have you ever seen one of those people? Now, how do I find the standard deviation? Oops. All right. Well, what's the square root of 49? And what's the square root of 64? So 8.5 is in the middle, right? I'm sorry, 7.5. 7.5 is in the middle, so if I'm in the middle over here, 50, that's half 7. 7 is what, 56? We need 57, so I'm going to say it's 0.076. What is it? Okay. Is it 0.075 or 0.075? I didn't hear what you said.
0.7549.
The square root of 0.57. I thought there'd be a 0 in there. Okay. I said it was 76. Y'all say it's what? Okay, well, I see either one. All right, anyway, so I just did that problem pretty much without a calculator. My whole point is, can you do these without a calculator? These you can. You just got to think a little bit and figure out what that 6 cents is for. I shut down a whole restaurant one time doing that. Giving somebody 6 cents after they rung it up, and they just locked them down. The head exploded. The manager had to come out. The manager had to bring a calculator to figure out the change. By then, I done walked out. Don't even get me started. That's about the time I had the lady at the Bilo try to scan the little bar, the thing that goes between somebody else's food.
She did.
Yeah, she tried to scan it. I think she was in La La Land or somewhere. All right, let's find a homework problem. See, these sections are not very what? They're not very long. Everybody should make an A on this test. If you don't, just consider yourself a what? There you go, or failure. Failure is better. It discourages more people. Are 14% of M&M's candies yellow? Mars Incorporated claims that 14% of its M&M's plain candies are yellow, and a sample of 100 such candies are randomly selected. Find the mean and the standard deviation, blah, 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 blah. Okay, of 100. Oh my gosh, they gave y'all 100 candies. So y'all gonna have to use a calculator on this. I'm being facetious. All right. I don't know if I can do it because I don't have a calculator. So the mean is equal to n, which is 100, times point what? Good job, Miss Slinger. You didn't have to type that in the calculator, did you?
I mean, no, but I was gonna do it. Really don't.
Oh, man. You didn't have to use a calculator because you just moved the decimal what? Two places to the right. All right, so now, without the help of the calculator, we're going to take this right here and I can't think, the variance is equal to 14 times 0.86. Say to yourself, how do you do that without a calculator? Well, what's 10% of 14? 1.4. So I'm going to go over here and I'm just going to say 1.4. And how many 10s do we have in this problem? 8. So that'd be 8 times that. So that'd be dang 11.3 or 11.2. Okay, so that's 80%. Well, if 10% is 1.4, then what's 1%? That's right, 0.14. And you're going to take 0.14 and multiply by 6. Now, it's not that hard because that's 84 cents. Think about it. 6 times 24, or whatever I said, 6 times 14, it's the same. 84 cents, or something like that. So if you take $11.20 and 84 cents, you're going to have $12 and what? Somebody tell me what the standard deviation is. Oh my gosh. And now you can take the square root of 12. You don't need a calculator because the square root of 9 is what?
33.
The square root of 16 is 4. 3.5 is in the middle here, so we got to find the middle here. 9, 16, 7. Half to 7 is 3.5. That'd be square root of 12.5. Oh my gosh! I say 3.4. Standard deviation is equal to 3.4. Somebody tell me what the square root of 12.04 is.
3.46.
Okay, 3.5. Okay, I'm supposed to go into cardiac arrest right now. Oh! Your phone went off. Get out of here. All right, 3.4. 3.5. I don't care if you put 3.4, 3.5. You did it in your head. Oh gosh, that'd make me the happiest person in the world. Hopefully you won't be at the cash register going, what's this simple? And that's it. So now you can do your handy dandy. And I'm going to use whole numbers. Or I'm going to round. My mean is what? 14 plus 4. 14 plus 4 is what? And 22. And 14 minus 4 is 10. 10 minus 4 is 6. So if you go and buy you some M&Ms, and you get 20, and this is just a regular 100 pack, just a small pack at the grocery store on the checkout aisle. If you got 25 yellows, then that is an unusual pack. If you have 4 yellows, then that is an unusual pack. And that's how you do 5 point whatever, 5.4. So 5.2, let's go over that right quick. Miss Dyer, what time is it? Oh, we got 5 Miss Dyers in here. Okay. What'd you say? 2:14? Okay, we got plenty of time. All right. So 5.2, what is it about? Probability, what? Distribution. Distribution is another word for what?
Chart.
The chart. X and P of X. And to give you an example, 5 games in the World Series, 6 games in the World Series, 7 games, and I told you 0.25, 0.5, and 0.25. And what's the 2 things we need to remember to check? They add up to 1. Summation of P of X has to equal 0.999 to 1.001. And what about each one? P of X, each P of X has to be, each P of X has to be between 0 and 1, which means they all have to be decimals between 0 and 1. And how do we find the mean? Well, let's do that in green because that's what we're going to be asked. I don't want to use that green, it's too bright, y'all can't see it, so hang on. So, to find the mean, what do? Summation of X times P of X. So that means we're going to take 0.5 times this, 6 times this, 7 times this, and do what with it? Add it up. And then to find your variance, you basically take the summation of what? X squared times P of X, and then subtract mu squared. And then, of course, the standard deviation is equal to the square root of the what? So whatever you get here, you just take the square root of it. So that's what you're going to be tested on in 5.2. Probably 3 or 4 questions. Really? I try, people. I try. There. All right, 5.3. I usually tell people just NTX. And what's special about this section? What do you got? What's in red that you have to remember? You have to put it in what? In the calculator. You have to put in the calculator in order. In order. And the only order is N, comma, P, X. If you do it in any other order, it's going to give you an error or an error, depending on where you're from. And it's not going to work. Now, if you have a calculator like Miss Swinger's, it's going to ask you to paste it, and you hit paste, and then you hit enter again, and it'll give you the answer. And basically, what kind of problem are you talking about? And you also use, let's see, what is it, second vars. And it's, what is 0? Is it binomial PDF?
Yep.
and then you type in N, comma, it's going to have a parenthesis, and then you type in N, comma, P, comma, X, and I think you got to add I don't know if you have to add the parenthesis or not, and then hit enter. And that's 5.3. So you're talking about 1 or 2 questions there. So how many questions you think I'm going to give you on chapter 5? Probably 10. And then you're going to have your 10 freebies that you should not be missing.
So it's 5.2, 5.3, and 5.4, that's all it's going to say?
Unless you want more. I'll be glad to go into sections we're not supposed to cover.
No.
All right, 5.4. Give me my formulas. Let's do them in green. The mean, N times P. And the variance, NT cubed. And then, of course, like always, standard deviation is equal to the square root of the variance. So, I would put the section 4, what is it, 5B? What does it say? Form what?
Form B.
Okay, Form B. So let me write that down because I have some people online that have to explain things. So, all right. What does it say? Unit 2, Form A is 4.2, 4.3, 4.4, and 4.6, right? And then Unit 2, Form B is 5.2, 5.3, and 5.4. Okay? So, that means that you should be working on, as well as the online class, y'all should be through with this. And y'all should be through with this. And y'all should be working on this homework tonight. And look for a test to be posted probably.
It's already posted.
It's already posted. I did post it. When's it due?
You just don't have to do that.
It says it's
Oh,
due
yeah, like the 21st of July.
Okay. Then y'all welcome to start working on it. Okay? And that means Tuesday when y'all come in, I'm not going to do a review of that. Okay? Because I'm not going to, I think most of y'all will probably take this test one time, maybe most twice. Because you should be able to get an A by the second time. Okay? That means next Tuesday we'll start chapter 6, which is going to be the bell curve chapter, which we talked about. All right, I got to get the roll right quick. And then I'll let y'all go. Let me stop this thing. Go ahead and